paper spray ionization technique, coupled to a high-resolution mass spectrometer, is widely used for healthcare diagnostics, drug detection, pharmaceutical development, and food safety organic fingerprint analyses. Now, a team of scientists at Savannah River National Laboratory have realized the advantages of also using PSI for analyzing inorganic actinides demonstrated for uranium. The team developed a cost-efficient and time-saving process that is positioned to become the go-to technique for rapid screening of nuclear materials.
We focused on paper spray, which is a method to use paper substrates as basically the medium for transport and ionization of the analyzed species. The capability was sort of a novel way of taking some existing new emergent technology in the bioanalytical space and basically transferring some of that previously developed R&D into a space that's more applicable to the mission spaces at SRNL.
Typically, reagents and sample preparation are necessary to characterize isotopes of interest, such as uranium for nuclear reactor fuel supply. But with PSI, isotopes can be determined with high accuracy and precision using as small as 8 microliters or nanogram quantities of material. The PSI process utilizes a sample on a substrate, like a paper wedge. The substrate is inserted into the instrument. A high-voltage charge is then introduced, resulting in a mist-like spray. Within seconds, isotopic signatures are detected, and within minutes, assessed for inorganic or organic materials. Sample preparation for PSI is straightforward, requiring de minimis preparation. A small volume of the sample is directly spotted onto a paper substrate and allowed to dry before adding a solvent. Samples can then be measured in real time using a commercially available manual attachment. The team is also improving the reproducibility and fidelity of the technique using SRNL engineered and manufactured new generation sample introductory systems, specifically designed for radiological measurements with fieldable application. Traditional mass spectrometry usually requires a staff of highly trained personnel to prepare samples, run instruments, and report data.
What we're doing is expediting that process. We're taking something that takes weeks, maybe even months to do, and we're doing it in seconds to minutes. We can sample, we can analyze, and then we can report all within one person at the location of the analysis. So at nuclear facilities, at radiation facilities, at emergency sites, we have a technology that can rapidly and reproducibly respond to an event or a controlled process.
To help validate the process, surrogate or authentic sample collections are fabricated at SRNL using known quantities of NIST traceable uranium compositions. Swipes and swab transfers of the particle-laden surfaces can be used for method testing or to calibrate instruments. The team leverages this capability to demonstrate efficacy of SRNL's PSI capability for near real-world samples. SRNL is also developing intuitive software and data analysis methods to verify detection limits and data integrity.
I have spent much of my effort actually writing open source code to ingest raw data files, to extract and find the subportions in the mass spectra that contain the information relevant to, say, determining the uranium isotopic composition or enrichment of the material, and then doing subsequent post-processing of the data, including calculating isotope ratios or enrichment, doing uncertainty propagation to determine the confidence with which we've made a given determination.
SRNL's paper spray ionization mass spectrometry technique can be used with minimal sample preparation to verify rapidly, accurately, and with high fidelity characterize the isotopic composition of various natural and anthropogenic materials. This analytical workflow holds promise for applications in nuclear forensics, international nuclear safeguards, non-proliferation missions, and new advanced reactor technologies.
We have now this sort of rapid development and this move in the energy direction to do microreactors. And part of the problem we always have is that we outpace the concerns. And so when we outpace the concerns, we need something that's boots on the ground, ready to go, being able to analyze the system locally and being able to tell whether these new technologies that are coming out are working properly. I think with the PSI group here, what they're offering is a real opportunity to be proactive while the technology is being developed.